131.22. So our objective is graphing linear equations. Okay, write that down. Graphing linear equations. The word linear in math means straight line, okay? And I want to use a different color. I like colors. You guys are going to find that colors for me are great because it helps me emphasize things. But this word right here means a straight line, not curvy. We will do curvy lines in here, but this first chapter will be all about straight lines, okay? Well, number 1 says graph y equals 2x minus 5. What the heck? What does that mean? Well, y is one value, x is another. And the reason we have two values is this. There are so many examples of how two things are related. One, I know a lot of you guys don't drive, but you will someday. Some of you guys drive, right? So you get in your car and you drive. You're paying attention, aren't you? Good. So you get in your car, you drive. You can drive for 5 hours, right? So two things, time and distance. Say it again. You get in your car, you drive for 5 hours, right? Two things, time and distance. So there's an awful lot of things in our society, in our world, that relate, right? So instead of distance and time, we just start with x's and y's, okay? But it's two things relate together. So since you see an x and a y, we make an x-axis and a y-axis, okay? So I'm going to get my ruler out. If you don't have a ruler, you don't have to have a ruler, but I do have rulers way over there on the table if you want to borrow a ruler. And I'm going to draw an x-axis and a y-axis. Hopefully this is a review of algebra, but my guess is that you haven't seen algebra for a while. Some of you haven't. So this is my x-axis. It's always going to be the horizontal axis. And this is my y-axis. As x changes, y changes. As x changes, y changes. Like distance and time. The longer I drive, the more miles I go. As one changes to the other. I'll say it again. And I get in my car and I drive. As one thing changes, the other does, right? If I drive more hours, I go more distance. Okay, so x and y are related. So here's how it works. Super easy, I promise. This number right here, we call the y-intercept. Well, here's the y-axis, right? That's called the y-intercept. Here's the y-axis. So this line that I'm going to draw intercepts at -5. 1, 2, 3, 4, 5, okay? It's really like my starting point, okay? It's like my starting point. So I find -5 on the y, put a dot. This number here needs to be a fraction. It really should be a fraction. And it is. If it's not a fraction, we can make it a fraction, okay? And it is a fraction because this number right here is called the slope. So we're going to take this line, we're going to start here, and we're going to walk, in a sense, walk up 2 over 3, up 2 over 3, because slope is rise and run. Watch, one more time. We're going to take this point, we're going to go up 2 over 3, up 2 over 3, and draw a line, okay? Because this is called our slope, and it's rise over run. It's that easy. So this is called our slope, and our slope is rise over run. Think about this. Some kids get this. You stand at the bottom of the stairs. At the bottom of the stairs, right? You want to go up the stairs. It may seem obvious. What do? You don't go forward first. If you go forward first, what are you going to do? You're going to fall down. Way up to you. Rise, then rise. Does that make sense? Same thing. So we're always going to go up 2 over 3 for this slope. Okay, so let's go ahead and draw that in, okay? I just run. I'm going to go up 2 over 3. 1, 2, 1, 2, 3. There's 1 point. 1, 2, 1, 2, 3. And connect the dots because it's a line. Put arrows on it, and there's the answer to the first graph. Show me thumbs up. Does that make sense? Thumbs up? Any sideways? Sideways thumbs are okay too. Okay, good. Let's look at example 2. So I have my y-intercept right there at -3. So I'm going to have to draw in put my x-y axis in. So draw my x-axis in. Draw my y-axis in. I'm going to start at -3 on my y-intercept. So I'm going to go 1, 2, 3, and there's my starting point, my y-intercept. So go down to -3, put a dot. And I have a slope. So the slope is this number. Here's my slope. My slope's the other number. This is my slope. This is slop. I needed that. This is my slope. My slope is 2, but I need a fraction, so I make it 2 over 1. Doesn't that make it a fraction? Take the number 2. 2 over 1 makes it a fraction, so let's start down at -3. And we're going to go, and we're going to walk it up 2 over 1, our slope. Start at -3, up 2 over 1, up 2 over 1, up 2 over 1. Walk it up, use my ruler, connect the dots. Okay. Now one of the things I see is these lines are going uphill because we read left to right. All these lines are going up. See how they're going up? That's because they have a positive slope. This one's going to have a negative slope, so it's going to go down. Now, it's missing some numbers. We're missing some important numbers. On number 3, that is a 1x, and that's a 1 over 1. So take a minute and see if you can graph this, okay? Just take a minute, see if you can graph this. I want you to try this, and then I'm going to come and show you what I get, okay? So take a minute, see if you guys can do number 3. Take a minute, see if you can graph number 3. You know where you're going to start, right? So my starting point is at, and then my slope, okay? So we're going to start at 1, and we're going to go down 1, over 1, and connect the dots. Okay? Thumbs up. How many kids got that on their own? I want to see. Okay, I see 1 thumb up. Only 1 thumb up. 2, 3. Okay. Able to do this without my help? Okay, number 4. There's no x. There's no x. Well, it's like a 0x. So y equals 5 looks like this. I'm going to help you with this one. My x-axis, my y-axis. Start at 5. 1, 2, 3, 4, 5. And there's no x. So it's like going up 0 over 1. Up 0, 1. So if you get an equation that's y equals just a number, it's a horizontal line. And here's why it works. Okay. Ready, Will? What's the height of this line? 5, right? What's the height of this line? What's the height of this line? What's the y? No, the y is always what? The y is always equal to what? What's the y always equal to? Isn't y always equal to 5, isn't it? That's why it always works that way, okay? All right, now let's take a look at number 5, okay? Now, if y equals 5 is this way, what do you think x equals -3 looks like? If y equals 5 looks like this, what do you think this one looks like? Just a guess. Wouldn't it be like that, up and down? This one's going to be vertical. So, all right, I'm going to put this in here. My x and y axis. This is the x-axis and the y-axis, right? -3 on the x-axis is right there. So I find negative 3 on the x-axis, and x equals negative 3 is just a vertical line going straight up and down. X is always equal to negative 3. X is negative 3. X is negative 3, okay? How am I doing? Okay, now example 6 is a little bit different. We have to start at 100. Now, come on, we're not going to make our graph super big. We're just going to scale it, right? We're going to scale it. So I see a 25, so I'm thinking, okay, I'm going to scale this for my x and y axis. Might start, I kind of know where I'm going. I'm going to start way down here, okay? So I'm going to scale it. I'm going to go by 25, so my scale is going to be by 25, so I'm going to go 25, 50, 75, 100, 150, 200. Okay, so I'm just going to scale it, right? Because I got to start at 100, so I'm going to change my scales to 25. My slope, the slope of this, what's the slope? Anybody know what's the slope of this line? What's the slope of this line? 25. How about 25 over 1? So I got to go up 25 over 1. So I'm going to scale this too. I'm going to scale this by 1s, 2, 3. So that I can go up 25 over 1. Up 25 over 1. So let's see. My starting point, right, is 100. So I'm going to start right there. There's my y-intercept. I'm going to apply my slope up 25 over 1. See, I went up 25. Didn't go up 1. I went up 25. I did not go up 1. I went up 25 over 1, up 25 over 1, up 25 over 1, because my scales are such that it is by 25s and 1s. So sometimes we have to change our scales to make it fit. That's okay. Better than getting a big old piece of paper and like staple in paper after paper and go all the way to 100. That'd be crazy, right? Okay, turn the page. All right, now example 7 is different. What we need, make yourself a star, we need to solve for y. Write that down. We need to solve for y. How you doing, Autumn?
Good. How are you?
Good.
What is this one?
This is, yeah, these kids are.
All right, cool.
Okay, all right, so if I take a look at what I have here, it's all y equals, right? It's y equals, it's y equals, it's y equals, it's y equals. So what I got to do is the same thing. I need to make this be y equals. So what I'm going to do is this. Just like our warm-up, I want y by itself. So here's my y. I'm going to get rid of the 2x. So to get rid of the 2x, just like our warm-up, I'm going to go minus 2x, minus 2x. Because that's going to cancel out the 2x, right? So I'm going to have a 3y, because that's gone. See how this works? Equals, well, 12 minus 2x. 12 minus 2x is not 10x. 12 minus 2x is just 12 minus 2x. You can't subtract these two because that's a number and that's an x. Do not subtract these. 12 subtract 2x is just 12 subtract 2x, okay? Then we're going to divide by 3 everything. Just like our warm-up. That'll cancel it. So let's see what we have. Got a y equals 4 minus 2/3 x. All right, I can graph this. I've got my starting point at 4 and my slope of negative 2/3. I'm going to go ahead and put in my x-axis and my y-axis. And I'm going to start up at 4. Let's see, 1, 2, 3, 4. Because that's my y-intercept. And then I'm going to go slope at 2/3. So I'm going to go down 2, negative, down 2 over 3. Negative 2/3. Down 2 over 3. And I'll draw my line. Yes, Tava, we can do this by intercepts, by the cover-up. But I want to show slope, okay? All right, thumbs up. That was a little bit harder. Thumbs up on that one. We got it to do y equals, didn't we? Right? Which is what we want. Now, number 8, same thing, except for it's just backward, but I can still do this, right? So I want to get y. I want the y by itself. So I want to solve for y. So I need to get rid of the 3x. All right, how do I get rid of the 3x? That's easy. I'll just subtract it, right? I'll go, okay, I'm going to go minus 3x because that'll cancel it. Now on this side I'm going to go minus 3x. Okay, so let's see what cancel, cancel, cancel. I'm going to have 8. That's 8 subtract 3x equals a negative 2y. Okay, 3x is gone. Subtract 3x, 3x, okay. But again, I want to solve for y. Y is right here. So let's get rid of the negative 2. Well, it's negative 2 times x. Negative 2 times x. So to undo that, we just divide by negative 2. Everything. Cancel, cancel, cancel. All right, that's a negative 4. Negative divided by a negative is a positive 3 over 2x equals y. Okay, I can graph this one. I'm going to start at negative 4. That's my starting point. And then I'm going to go up 3 over 2, up 3 over 2. Okay, so graph this in. Put my x-axis in. My y-axis. I'm going to start at negative 4. 1, 2, 3, 4. And then my slope is up 3 over 2. So slope of up 3 over 2, up 3 over 2, up 1, 2, 3, 1, 2, up 1, 2, 3, 1, 2, up 1, 2, 3, 1, 2. I'm just going to make my line nice and long. Draw in the line. Now, I like arrows on my line. I like arrows, arrows, arrows. You guys see the arrows? I like arrows. Why are the arrows important? Come on, you guys are smart enough. Why are the arrows important? Why you got to have the arrows? How long is this line? How long is this line? It goes forever, right? So that's why I like the arrows, okay? Okay, show me. It's okay. It's okay if you show me here. Show me here. I just want to see, okay? All right, good. So we've got a little bit of an assignment that is on a worksheet I want you to do, and we've got time to get it done. And then I've got a thing called an exit ticket, just for check to make sure you guys, before you leave, we'll execute it. So here's the thing. All you gotta do is try, right? You just try. So here's your first chance today to get your points to put into the big jar, right? If you don't do your homework, you're lazy, then you're wasting your time and my time. Okay, so I want everybody working, okay? So let me stop the recording. And our assignment, and I'll have Tava pass out a second, is this. First page is solve for x. First page is solve for x. Second page is graph. You might need graph paper. If you don't have graph paper, I'll find graph paper for you. Thank you, Tava. I'm going to put you to work. You know that, don't you? Just get used to it. Okay, and stop my recording.